So let's talk about this famous person example. So this famous person example is a Java class that is available in your modules. So this class has three attributes, so the three properties, namely first name, last name, and the year they were born to identify what this person, famous person is. So this Java class has three comparisons methods, and also actually two comparisons method. One is called equals, second one is called compare to, and the third one is called string. Actually, there's another one that makes use of a comparator class in Java, plus a whole bunch of setters. So without further ado, let's kind of look at, review this famous class. So this famous person looks like this. You have these main attributes. Actually, there's more. There's one more called fact. The standard constructor that basically initializes these first name, last name, fact, and year of birth, plus the standard accessor methods that gets you the first name, last name, fact, and year of birth of the famous person object. And notice that in the beginning that we have two of these things. One is the comparator, and the other one is a comparable interface. So Java provides two interfaces to sort objects using data members of the class. One of them is the comparable, which is what's implemented here, and the other one is simply a comparator. We'll take a look at how both of these are used specifically in our slides. We'll look at the comparable one, but if you move down there, you'll see the compare to. Okay, so let's not get too much into details here. The compare to is actually part of the comparable interface. That's something that we're overriding. There should be actually an override here. Okay. This equals, on the other hand, something that we saw already from your circle, right, previous lecture. That circle object comparing against the other circle objects in terms of their radius makes use of the Java len object. So the Java len object has a number of methods that you can overwrite. One of them is called equals. So this is an object method. And the other one's called toStrings, right? There's a whole bunch of these things. So I just wanted to make sure that the genesis behind what these methods and where they come from. So that is famous person. We'll get back to this one a little bit. So if you look at the famous person class, let's investigate this equals. So this equals inherits from your Java object. And it's simply doing by default two things. One is checking to see if the object is actually the same as itself. So you're comparing two objects that are really the same to each other, then yes, true. Or if the object is not null, or not coming from the same class, if that's the case, then false. So generically, right, Java object provides these two functionality to check to see if the object is true or false using equals. But you want to do something more, because with the famous person, we also have additional attributes associated with them, namely their first name and last name. So if you want to do comparisons, for example, in this case, we can compare both of their first and last name, see they're equal to each other, right? Okay, first thing you need to do is to ensure that your arguments that passed in is casted to the famous person instance. And then you can do the famous person first name against this, right? So this is the one that you're comparing against to see if their first name and last names are equal. So recall that your first name and last name, both of them are string. So when you do a dot equal on top of a string, this equals is part of the string class, which is also a part of the object class. So again, you're doing the equals comparisons. So if both of them are string, that means they will only be equal if they are of the same instance, right? Or references. Last name too, the same. So this gives you, as a matter of fact, no, because now the equal sign applies to the string actually overrides the generic equals. So if you go into the dot equals inside a string object, you will see that this equal also compares the value, right, against the other value first name. Meaning, if my name is Joe, and this famous person is also Joe, then this equals gonna give you true when you're using string as an object to invoke that dot equal. Okay, does it make sense? I hope this makes sense here. So that is the famous person override of the dot equals methods. So this one, let's move on to the other parts. Okay, now recall that we were talking about collection. So collection does not have this sense of ordering, right? Elements sitting in there could be anything. So what you need to do is to establish a uniqueness to an object or element sitting inside this collection, and use that uniqueness, which we call keys, to kind of do something about it, to see which one is bigger, which one is, it's got the same value than the other. And I think the most important part is to be able to sort these elements based on their keys. So this key does not have to be an integer. It could be a string, okay? So a key to class is something that when you pass, let's say, for example, when you establish a collection, making use of collection ADT, you have to have a unique key associated with the class. Sometimes it's a collection of keys. So this key could be a collection of attributes. So like first name and last name combined, when you concatenate them, becomes a unique first name and last name of the person. And that becomes the key that you can use to separate these things. Okay, one example is back in the circle object where we're talking about radius. Radius is the key for the object. For famous person, it could be a first name, last name, or it could be a first name, last name, fact plus the year they were born, right? So it's really up to you, the developers, to establish what this key is. Now, why we're talking about keys? Well, keys is important in comparison, okay? And because we need to establish some sort of order in this collection to enable in the future sorting of the element, this keys become paramount important. So retrieving object based on their keys. So for example, let's just take a look at this object, famous person object. Everything is the same with the exception of the very last two. So this year of birth is different. So first name and last names are the same, but it looks to me that they're two different famous person because one person has this, the other person has this, one person has this, and the other person doesn't have anything. So they cannot be the same. Now, if you were to establish a key up front, saying that the key is first name and last name, and do the retrieval from the two objects and do the comparisons, we could still be wrong. So we need to do a lot more about, comparing object to object, and these comparison methods that we implement as part of the collection, actually as part of the object, to determine their orders inside the collection becomes very important. All right, and do not worry so much about these application and packages. These are very particular to the textbook that you have. I don't think this is important, so I don't have it in the modules. But then again, let me know if you need them. Ordering objects. Okay, so in order to check objects for equality, there's another type of comparisons we need. So this is very important because now we're talking about sorting the elements inside the collections. So it's actually this sorting, right? So what does that mean? Sorting means that there's some sort of ascending and descending order in the objects that we have in the collection. And in order to establish which object is greater than the other, or smaller than the other, or equal to each other, right? Less than, equals to, and greater than each other, we have to make use of another Java utility. So we saw them in the famous person.java earlier, that there is a comparable interface that you can implement. There's also another comparator interface that you can implement to ensure that the class provides this functionality. What kind of functionality are we talking about? What is this? So this is the support, right, for sorted collection, the ability to tell that one object is less than, equal to, or greater than the other object. So this might still be somewhat abstract. So let's look into a little more concrete examples. So the comparable interface is something that is available in this is available in Java libraries. When you implement this comparable interface, you have a choice of implementing or overriding its compare to methods, or just use the default one. So typically when people do implement a comparable interface, you'll see a custom compare to that overrides the default. Basically, what this compared to is you're comparing the two objects. So one is this, which is itself, against the other that's being passed in of type t, right? So the compare to also returns an integer. So the integer could be a negative number, positive number, or zero. So zero signifies that they are equal to each other. Less than signifies that the negative number signifies that they are less than. So O1 is less than O2. So assuming this is O2, and O1 is this, right? So there's this O1. O1 is this. So THIS. Now, if this is greater than O2, then in that case, you'll get a positive number. Sometimes we use these numbers, like negative numbers being -1, positive numbers 1. It depends on, what is being used to compare these things. Let's say if you use a equals value against the equals methods on the string, then you're going to get a certain numbers. So this is implementation specific, right? Whatever these numbers are. But generally speaking, that's what compare to should return, either a negative number, 0, or positive numbers. So compare to method returns an integer value that indicates the relative size of the relationship. So this is what we're talking about, right? So if you have object 1 against object 2. So this object 1 could be a whole string. And the keys I established O1 and O2s are first name and last name. These are strings. When you compare the first name and last name against the other first name and last name, these are not integer, obviously, because these are string. The relative size means which string is bigger, right? So in the context of the string, then we invoke what's called the natural order of the string. We'll take a look at this in the next slides. But anyway, the relative size of the relationship dictates the order of these two elements, and that establishes a relative size relationship in terms of that number, either negative, 0, or positive. Okay, so let's take a look at even more concrete examples in the next slides. This is a compare to examples that makes use of the comparator interface. This compare to takes in arguments from the outside, comparing against this THIS. So the very first line. Now this is the overwritten logic inside this famous person. So it's up to you how you like to implement this whole logic here. So the author chooses to do this. Now, if this last name is not, right, it's not. So this exclamation says not equal to the other last name. What does that mean? Well, recall that this dot equals is part of the last name. So what is last name? Last name is a string object. So in the string object, the dot equal methods implements, are these strings the same or not, right? So it's basically saying, is Joe the same as Joe, right? And that comparison looks into lexicographical or the natural order of the string, okay? So let me just type this up. The natural order of the class if string, right? Then we use what's called lexicographical comparison. And there is a lexicographical order. So if you Google this around, you'll see lexicographical comparison is what we meant by the natural order of the class. So each string in general is a collection of characters. When you're comparing a string against the other string, lexicographical comparison is a standard that the industry uses to compare to see which character is actually bigger than the other. For example, a string A as in apple, uppercase has higher precedence has higher value than the lowercase a, apple. And that is through the ASCII, basically, roughly speaking, ASCII, orders in an ASCII table. But sometimes when you have a very complicated, string that has alphanumerics in it, right? So one example is ABC, 1, 2, 3, and then ABC. And you want to compare this against ABC, 1, 2, 1, 3, 2, ABC, right? So which one is bigger, right? So lexicographical can tell, order is going to tell you which one is relatively bigger than the other. But anyway, dot equals makes use of that. Now, What happens if this is not the case? Well, if this is not the case, last name is not equal to the last name, then you wanted to see if they're actually compared to the other last name. So this is um, the point where you be getting the actual number coming out of it. First, check to see if the last name is, if this is not equal, then how about is last name versus the other last name? So this actually gives you another sort of chance to see both objects are the same or not in their relative order. Now, if their last names are the same, right, then you compare the first name, okay? So this compared to that we're looking at here is actually part of the string, okay? This is not part of famous person. We're actually making use of the default compared to, which is an overwritten method inside the string. And this one is part of the string object called first name. Okay, same thing here too. So, with the last name here. So this gives you kind of a check and, to see which object is bigger or not, right? So compared to also returns, when you do it this way, returns a negative number, 0, or positive number. So both of these is going to give you something. So when you check your first person against the other first person instances, you'd be comparing their first name. If not the same, then compare their last name compared to last name, their natural order. If not, then compare their first name, natural order. Okay, so this is the logic that we use. Now, if you look at the circle example that we had, that circle has a equals method. And then you'll notice that the circle equals is pretty similar to what we have here in the compare to, in that, both kind of returns, some numbers. But in this case, that equals method, at least for the circle one, does not necessarily return a number. It could be a Boolean, right? It telling you whether this is the same or not. But essentially what you need to do is you want to be a little more details about the relative size, right? Basically fathoming or ascertaining which object is actually greater than the other, not just whether they're equal to each other, right? Because this comparison will let you order the elements when it comes to sorting. Okay, so this is the compared to examples. This part equals is what we just went through, and this compared to is what we just went through. So let's pay attention to what this comparator is. First of all, there's also this toString. So this toString is the overridden method replacing the default one from the Java Lang object. Okay, so this replacement calls for the first name plus last name plus this custom text printed, returning back to the color. If you scroll all the way up, you see this comparison. So the comparable interface is being implemented here. That gives you this compare to. And again, this compare to is an overwrite right here, okay? So the other actually misses this. Now, whether you want to overwrite this or not, it doesn't really matter if you don't have it here. But what I want you to pay attention to is actually this one. So this is the second interface. It's called comparator. Now, in order to make a common class of this interfaces, you have to actually instantiate it. So this very last part, which is what the slide didn't show, is this comparator. So this is a static. So static basically means that you are creating a separate instance away from this class. So this static is no longer the same class instance, but something else. So when you invoke this year of birth comparators, you're actually making a copy. You're actually making an instance of this comparator class. And this comparator class being static returns a new comparator of type famous person. And because the comparator itself is a interface, and there's an abstract method in there called compare, you have to implement this compare, okay? So right now, the author chooses to implement this compare using year of birth from the two elements, and then do the subtractions that way, and to see which one is bigger or not. So ultimately, you can actually swap this, or you can multiply this by 2, divide by 3. It's totally up to you. So the other chooses to do this. Now, if you were to say, I don't want to compare the year first, I want to compare the first name and last name, then, in that case, you can go back, to using the compare to. If you recall what I said earlier, a string has a compare to method. So string actually implements comparator already. So what you can do is, I'm going to use last name. You can do a compare to, and then elements two, element two, oops, element one against element two, last name. Okay, so let me just expand this. So this is what you can have instead of that return. Down there, you can have the elements one, last name compared to, and a semicolon at the end, of course, to essentially get you an integer as well for the compare. So whether this logic should be done on the last name as a key, on year of birth as a key, or a combination of the first name and year, right? So it's totally up to you. But this is another way of kind of establish that integer, relative size of the objects coming from elements one or two. The other difference between this comparator and the comparable is that comparators compares two external objects, right? So you can see the two external objects is element one and element two. Whereas the comparable interfaces is comparing against one external object against itself, right? So it's this, right, against the other, right? Whereas the comparator is taking both of these, right, from the outside and do comparisons that way. So the comparator in comparison is more standalone than the other way of implementing that interface, but both establish the same thing. The point of it is that you would override your own comparisons methods to establish the relative size of the two objects that you're comparing. Okay.